I'll be presenting this fake news detection model that I recently built. So fake news is all around us, whether we can identify it or not. Individuals and organizations publish fake news all the time, whether it be for a persuasion tactic or to simply override unfavorable truths. Take the search for a COVID-19 vaccine, for example, an issue that's especially relevant in our current times. Before a vaccine came out, there were some sources that stated that there was already a fully effective vaccine available. Some stated that it was coming very soon, and others stated that it would take decades for a safe and functional one to be released. But trusting and following the wrong source can definitely lead to more harm than good. So now the question becomes, which websites do we trust and which do we ignore? Well, in most cases, it might not always be that clear as to which sites to trust or reject and which sites are real or fake. But fortunately, big data can save the day for us. In today's world of ever-growing data streams, one can imagine crunching through the volumes of data to detect patterns, which can then be analyzed to separate out real news from fake. And that's exactly the project that I executed on, a fake news detection machine learning model that utilizes advanced natural language processing techniques to classify news websites as either fake or real. So this machine learning model uses binary classification to identify whether a news site is fake or real, in which an output of 1 indicates that the website is most likely fake, and 0 indicates that it is indeed trustworthy. It'll take in a list of website URLs and corresponding raw HTML as input data, and will train a logistic regression model to output a label of either 0 or 1, depending on whether the website is fake or real. And so the core of this model comes in the form of the various natural language processing techniques deployed to transform the input data, which is previously in the form of words, into numbers that the machine can understand and learn from. And so I've transformed this data from words to numbers by creating a set of several functions generally referred to as featurizers. And so the purpose of these featurizers is to extract key features of the URL and the HTML that may help predict the trustworthiness of the site and transform the data into numerical values to input into the logistic regression model. So to obtain the data necessary for my model, I scraped the web for news sites and compiled a set of about 2,500 sites, consisting of roughly 50% fake and 50% real. I then split my data into a training set, a cross-validation set, and a test set. So I created my first baseline featurizer to be a domain featurizer that extracts basic features from the domain name extension of each website. So like .com, .net, things like that. This domain featurizer takes in a URL and an HTML and returns a dictionary mapping the feature descriptions to numerical features. And so the accuracy of this model was only 55%, which was not surprising as the domain extension, while it could provide some clues, can't be the deterministic predictor of a website's trustworthiness, simply relying on the domain .com or whatever it might be. And so the key problem with this model is that there was simply not enough information. And so to combat this issue, I decided that my next step would be to make use of specific and potentially predictive keywords of the HTML, in addition to the domain extension, to feed into the logistic regression model. And so after a series of steps, I used a logistic regression model to get an accuracy of 73%. And so this model performed considerably better than the domain method. But as this is still a relatively simple method, I started to think of some more nuanced approaches. And so the meta descriptions of a website's HTML is a great source of information conveying the core content of that website. And so as an improvement to the keyword featurizer, I created this bag of words NLP model, or I used this model. And once I obtained the score reports, I observed that all of the metrics yielded much higher percentages than before. But a shortcoming of this bag of words model was that it only looked at the counts of the words in the description for each website. But then I wondered if there was a way to somehow understand the meaning of the words in the descriptions for each site, because definitely understanding the meaning would help predict whether it's fake or real. And so this is where word vectors come in. I utilized a model called GLOVE to accomplish this task, to find the meaning of the words in the websites. And so this model yielded an accuracy of about 87%. And so given that I tried out several different featurizers and I observed the score reports for each, I was curious to find out if I could obtain improved results if I combine all of the featurization approaches. And so the first one, domain, and then the keyword featurizer, and the bag of words model, and then lastly, the GLOVE. And so I concatenated all the vectors, and I passed this through the logistic regression model and obtained an accuracy of 91%, which was the highest yet. So now that I had built my model after several iterations, it was time to test it out on the unseen data to observe the real accuracy of the model. And so I obtained the score reports and observed that my model predicted the trustworthiness of news websites that it had not seen before with 91% accuracy, and that brought the project to a successful end. So as with any machine learning model, there are places for improving the score metrics even further, such as obtaining a larger data set, developing more ways to predict the trustworthiness of the website, maybe using more nuanced approaches, different models. But that said, this model seems to be a pretty reasonable predictor for the trustworthiness of a website, and certainly makes the task of vetting sources much easier and faster than manual labor. And in a society filled with fake news, a model such as this could have a transformative impact. So thank you for listening.